So hello everyone, now in this video I'm going to start exercise 21E. For the previous one, please check the description box, the link will be there. You can also visit our website, the website link is in the description box. So here the first problem, sum number 1. Here you have total 17 problems in sum number 1. So the first one, prove the following: 1 by cos A plus sin A plus 1 by cos A minus sin A. Okay, this one equal to, you have to prove that 2 cos A divided by 2 cos square A minus 1. Okay, so here the LCM, you have cos A plus sin A, then cos A minus sin A. So you know the formula, A plus B into A minus B is the formula of A square minus B square. So you can write down here cos square A minus sin square A. Okay, because the first one here the denominator is cos A plus sin A, second one denominator is cos A minus sin A. So A plus B, A minus B, so the LCM equal to A square minus B square. So write down here cos A minus sin A and here cos A plus sin A. So sin A cancel out, this one equal to 2 cos A. Okay, now in the right hand side you have only cos square, okay, in the denominator. So write down here cos square, and in the place of sin square you can write down 1 minus cos square A, because sin square theta equal to 1 minus cos square theta. So upper one 2 cos A, then here cos square A minus 1 plus cos square A. So 2 cos A, then 2 cos square A minus 1, that one equal to your right hand side. So it's proved. Next one, number 2. Number 2, here cosec A minus cot A, this one equal to sin A by 1 plus cos A. So cosec means 1 by sin A and cot means cos A by sin A. Okay, so here sin A is the LCM, so this one 1 minus cos A. Okay, I hope it's clear. So as here the upper one is 1 minus cos A, so if you multiply the upper one with 1 plus cos A, then it will be 1 minus cos square A. Why I multiply this one 1 plus cos A? Because here in the numerator you have sin A and 1 minus cos square A is the formula of sin square A. Okay, and in the denominator you have 1 plus cos A in the right hand side. So here just multiply up and down with 1 plus cos A. So 1 minus cos square A and the lower one sin A into 1 plus cos A. No need to multiply sin A with 1 plus cos A. So write down here sin square A, this one here sin A, 1 plus cos A. So sin A will be cancel out, your final answer sin A by 1 plus cos A. Clear? Okay. Now next one, sum number 3. In sum number 3, left hand side you have 1 minus sin square A, 1 plus cos A. Right hand side you have only cos A. So first here 1 plus cos A is the LCM. So 1 plus cos A minus sin square A. Now here 1 plus cos A, and in the place of sin square A write down 1 minus cos square A. You know that formula? Okay, so here 1 plus cos A minus, and here 1 minus cos square A, so here you can apply A square minus B square formula. So A plus B, then A minus B, that means 1 plus cos A into 1 minus cos A. So 1 plus cos A is common in the numerator. So 1 plus cos A common. So 1 minus, then again 1, then cos A, because minus minus is plus. Okay, 1 minus 1 minus cos A. So that's why 1 minus 1 plus cos A. And denominator you have 1 plus cos A. It will be cancel out. Here 1 1 cancel out. So final answer cos A. Next, number 4. In number 4 here 1 minus cos A divided by sin A plus here sin A divided by 1 minus cos A, that one equal to 2 cosec A. So here the LCM equal to sin A into 1 minus cos A. So the numerator first one 1 minus cos A whole square plus sin square. Okay, because 1 minus cos A multiply with 1 minus cos A, it will be whole square. Sin A into sin A, it will be sin square. So 1 minus cos A whole square means A minus B whole square formula. So A square then plus B square minus 2AB, then last one sin square A, and in the denominator sin A into 1 minus cos A. Now you know that cos square A plus sin square A equal to 1. So 1 plus 1 minus 2 cos A. Here sin A, then 1 minus cos A. So 1 plus 1 2, 2 minus 2 cos A. If 2 common, it will be 1 minus cos A. So 2 into 1 minus cos A, 1 minus cos A. Now it's cancel out. So 2 by sin A. 1 by sin A is the formula of cosec A. So your right hand side equal to 2 cosec A. It's proved. Next one, number 5. Number 5 here, cot A divided by 1 minus tan A plus tan A divided by 1 minus cot A. Okay, this one equal to 1 plus tan A plus cot A. Okay, so here 1 minus tan A, 1 minus tan A, this one, and this one here. So do one thing, first change a little bit. So this one here cot A 1 minus tan A plus here tan A, and in the place of cot you can write down 1 by tan. Okay, so here it's cot A 1 minus tan A plus this one here tan A, and it's tan A minus 1 when the LCM equal to tan A. So here cot A 1 minus tan A plus here tan square A, and then tan A minus 1. So the first one write the same, cot A 1 minus tan A. From the second one, from the denominator, if you common minus, so it will be 1 minus tan A. Okay, and plus minus it will be minus, so tan square A. Now here cot A minus tan square A, then here 1 minus tan A. Okay, so in the numerator you have cot A minus tan square A. Clear? In the denominator you have 1 minus tan A. So now in the place of cot A you can write down 1 by tan A minus tan square A. Here 1 minus tan A. So here the LCM equal to tan A, so it will be 1 minus tan cube A. Here tan A into 1 minus tan A. Now 1 minus tan cube A is the formula of A cube minus B cube, and you know the formula, it's A minus B A square plus AB plus B square. So here 1 minus tan A, it's A minus B, then A square means 1 plus AB means tan A, and then B square means tan square A, divided by tan A, 1 minus tan A. So 1 minus tan A, 1 minus tan A cancel out. Now if you divide tan A separately, so 1 by tan A, that one equal to cot A, then tan A by tan A, that one equal to 1, tan square A by tan A, it will be tan A. So that one is equal to with your right hand side. So it's proved. It's a little bit lengthy problem, so observe it very carefully. Okay, now the next one. Next one, sum number 6. In sum number 6 here, cos A by 1 plus sin A, then tan A plus tan A, and this one equal to sec A, right hand side equal to sec A. So as here cos A 1 plus sin A, okay, clear, and tan means sin A by cos A. So here the LCM equal to cos A into 1 plus sin A, then cos A into cos A, it's cos square A, and sin A into 1 plus sin A, it will be sin A plus sin square A. So as you know that cos square A plus sin square A equal to 1, then 1 plus sin A, here cos A into 1 plus sin A. So this one cancel out, 1 by cos means sec A, and it's proved. Next one, sum number 7. Sum number 7, sin A by 1 minus cos A minus cot A, this one equal to cosec A. So this sum is as same as the previous one. So I hope you can solve this one. So let's move on to the next problem, sum number 8. Sin A minus cos A plus 1 divided by sin A plus cos A minus 1, and right hand side you have cos A by 1 minus sin A. Okay, so now as here the upper one you have sin A, then minus, if minus common it will be cos A minus 1. Lower one you have sin A plus, in bracket you can also write down cos A minus 1. So as here the upper one you have sin A minus cos A minus 1, lower one you have sin A plus cos A minus 1. Okay, so just multiply with the opposite one in the denominator. So as here cos A minus 1, here sin A plus cos A minus 1. So multiply this one with the opposite one, sin A minus cos A minus 1. So this one will be also sin A minus cos A minus 1. Okay, as here in the denominator you have sin A plus cos A minus 1. So multiply up and down with the opposite one. That means sin A minus cos A minus 1. So the upper one will be sin A minus cos A minus 1 whole square, and the lower one it's A square minus B square formula. So sin square A minus cos A minus 1 whole square. Clear? Okay. Now for the upper one, A minus B whole square formula. So A square minus 2AB, and then here B square. B square means cos A minus 1 whole square. Lower one here sin square A, then minus cos square A, to be plus 2 cos A, then minus 1. Okay. So here sin square A minus 2 sin A cos A minus 1, and this one here cos square A minus 2 cos A plus 1. Clear? Okay, and here it's cos sin square. Okay, sin square minus cos square plus 2 cos A. So sin square means sin square minus 1. Okay, sin square minus 1 equal to minus cos square A. then again minus cos square A plus 2 cos A. So in the numerator you have sin square A plus cos square A, that one equal to 1, then 1 plus 1 equal to 2. So 2 minus 2 sin A cos A, then plus 2 sin A minus 2 cos A. And the denominator you have 2 cos A minus 2 cos square A. So write it down here, 2 minus 2 cos A, then write down 2 sin A, just rearrange it. So here 2 sin A cos A, and lower one, if 2 cos A common, it will be 1 minus 2 cos A. Sorry, 1 minus cos A, not 2 cos A, 1 minus cos A. 1 minus cos A. Okay, so from the upper one, first common 2, it will be 1 minus cos A. From the next part, common 2 sin A, it will be 1 minus cos A. Lower one, you have 2 cos A, then 1 minus cos A. Okay, so now in the numerator, you have 1 minus cos A into 2 plus 2 sin A. Here 2 cos A into 1 minus cos A. So 1 minus cos A, 1 minus cos A cancel out. From the upper one, common 2, so it will be 1 plus sin A divided by 2 cos A. Okay, so here 1 plus sin A by cos A. 1 plus sin A by cos A. Okay, now here again multiply this one with 1 minus sin A, because in the right hand side you have 1 minus sin A in the denominator. So the upper one will be here 1 minus sin square A, because A square minus B square formula, and lower one cos A into 1 minus sin A. So it will be here cos square A, then cos A, then 1 minus sin A. So 1 cos A will be cancelled out, so it will be here cos A by 1 minus sin A. Okay, again it's a very difficult problem and also lengthy problem. So as here I repeat, here first you have sin A minus cos A plus 1, then sin A plus cos A minus 1. So as here plus, so multiply this one, the opposite one. Okay, multiply the opposite one up and down both. So that's why here I multiply this one with negative 1 with the numerator and denominator both. Clear? So now here these two are same, so it will be here whole square, and the lower one is the formula of A square minus B square formula. So here sin A minus cos A minus 1 whole square, that means A minus B whole square formula. So A square minus 2AB, last one here B square, and in denominator you have sin square, then cos A minus 1, again A minus B whole square formula. So now from the upper one, here finally we get 1 plus sin A by cos A. Okay, that will be your answer. But as here you have to prove cos A by 1 minus sin A, 1 minus sin A in the denominator. So that's why here again multiply 1 minus sin A with up and down. Clear? Okay, so here the upper one is again A square minus B square formula. So 1 minus sin square A, lower one cos A into 1 minus sin A. Okay, now 1 minus sin square is the formula of cos square A, that's why cos cancel out. So 1 cos A will be in the numerator, so cos A by 1 minus sin A, that is your right hand side, and it's proved. Okay, so guys, if you like my video, please share this video and please subscribe my channel. Okay, now next one, sum number 9. In sum number 9, here you have under root 1 plus sin A, 1 minus sin A. Okay, and this one equal to with cos A by 1 minus sin A. Okay, cos A by 1 minus sin A. So as here in the right hand side, the denominator you have 1 minus sin A. So do one thing, multiply 1 minus sin A up and down. Okay, multiply 1 minus sine A up and down. Don't multiply 1 plus sine A. Remember this one, okay? Don't multiply 1 minus sine A up and down in that case, because in the right hand side denominator you have 1 minus sine A. So 1 minus sine A should be in the denominator. So here in the denominator you have 1 minus sine A whole square, and the upper one 1 minus sine square A, because A square minus B square formula. So it will be here cos square A, and this one here 1 minus sine A whole square under root. Now root over cos square A means only cos A, and 1 minus sine A whole square under root means only 1 minus sine A. Okay, so this one is proved. Now next one, sum number 10. Sum number 10, again you have 1 minus cos A by 1 plus cos A, that one equal to show that sin A by 1 plus cos A. That means in that case here you have to multiply 1 plus cos A up and down. Okay, this sum is as same as the previous one, so I hope you can solve it.